Hi, welcome to Algebra 2, Unit 3, Lesson 3, Simplifying Radicals and Solving Equations with Rational Exponents. So as you do this lesson, remember that we're talking about a concept here, not just always square roots. So as we start getting into third roots, fourth roots, I want you to look for the pattern so that even if you were given something that had to be simplified to the 50th root, you can still apply the same concept that we're doing right now with square roots. And we're going to start with square roots because it's basically what you're used to at this point. So if you take a look at A, it's saying, what is the square root? We're going to just simplifying here. There's no numbers. So what is the square root of x to the 6th? So in other words, what it's asking me is what number times itself gives me x to the 6th power. So as you can see, when we have the same base, we keep the base and we add the exponents. So if it has to be the same, we're simply going to be taking half of that. All right, so the answer to this is x to the 3rd power. We're taking half because it's the square root. All right, so we're dividing this number by 6. So as long as the exponent is divisible by an even number, divisible by 2, then it will be a perfect square. So this one, 10, is divisible by 2, so this is simply going to be x to the 5th. X to the 20th is x to the 10th. X to the 36th. Now be careful because you're thinking square roots. Your brain all of a sudden starts having a little bit of a meltdown because it's thinking, okay, well, 6 is the square root of 36, but that's not what we're doing here. We're saying, again, what number times itself is equal to x to the 36th? So 18, because 18 plus 18 is 36. Then we can start getting into some situations like in letter E, where this is raised to the 5th power. So what we're going to do is we're going to basically simplify like we did in Algebra 1. We're going to pull out a perfect square, and then whatever left over, we're going to put in the right-hand side radical. So in this situation, in other words, what I can take out of here is I can take x to the 4th out. That's a perfect square. But that leaves an x left over, right? Because x to the 4th times x is x to the 5th. But now what we're going to do is we're going to take that rational part on the left-hand side, and we're going to rationalize it. So what is the square root of x to the 4th? Hopefully you're telling me, and I can't hear you. It's x squared, and then keep that rad x next to it. So that's what this is simplified. Well, x to the 9th is the same situation. Again, don't let your brain start getting in the way here. X to the 9th, think about cutting it in half. Well, 9 does not, because this is a square root. Again, remember, we're thinking about this in different roots here. So right now we're thinking about square roots. So in other words, this exponent here has to be divisible by 2. And in this case, it's not. But we can pull out an x to the 8th, which leaves an x left over. And the square root of x to the 8th is x to the 4th, rad x. Same thing with x to the 11th. We're going to pull out an x to the 10th. It's a bad x. Sorry about that. An x left over. So you have x to the 5th, rad x. So the only thing you can have left over underneath the radical is an x. Because if you're divisible by 2, you're only going to have at least, or at most, one x left over. So here is going to be rad to the x to the 24th, rad x. So x to the 12th, rad x. And then we start adding numbers into the mix a little bit. So again, at any time here, you guys know, pause, write things down. This is a really good time to maybe pause and write these down. Make sure you have them all done before we move on to I, J, and K. And L, M, and N. Okay, didn't see all those down there. All right, so we're doing the same thing here. We're just taking it slowly. We're trying not to, stress ourselves out. So when we're doing this one, we're going to do exactly the same thing. When I taught Algebra 1, I used to say perfect square and I don't care. So on the left-hand side, we would want to pull out the perfect square of 8. So think about the perfect squares. While we're talking about perfect squares, it's very simple to say 2 squared is 4, 3 squared is 9, 4 squared is 16. All right, so think about those perfect squares. So what number can I take out of an 8 that's a perfect square? Now, you want to take out the largest number. Then the only possible one that we have is 4. So 4 is the perfect square, and 2 is left over because 4 times 2 is 8. And now we're going to do exactly what we did up above. We're going to take out an x to the 8th power, anything that's divisible by 2, and x left over, a y to the 10th power, and with a y left over. So this is not going to change. We're not touching that because that's the irrational portion of it. But now the part on the left is the perfect square. So let's take the perfect square of 4x to the 8th, y to the 10th. Well, it's simply going to be 2x to the 4th, y to the 5th. So let's not overthink these too much because they're really not that hard. All right, so moving on to J. We're going to do the same thing we just did. We have a perfect square and what's ever left over. So now 32, well, if we're not at there, you're only at 16 right here. So you could do 5 squared is 25, 6 squared is 36. So 32 falls between 5 and 6, but 25 doesn't go in evenly into 32, but 16 does. So the perfect square is going to be 16 times 2 is 32. So what goes on the left-hand side is that perfect square. And then we're going to have x to the 3rd, y to the 4th, I'm sorry, y to the 8th. I'm losing it here. See, even my brain doesn't work so well sometimes. I'm taking the square root of it right away. So here I'm going to have x to the 6th, y to the 8th, and there's nothing left over underneath that radical 2. So in other words, we can get rid of some of this here. And our final answer, now we're going to take this and take the perfect square of it, which is 4x to the 3rd, y to the 4th, rad 2. Square root of 2, however you want to say it. And that last one, k, is just very simple to the 51st power. But again, sometimes we still make mistakes. Perfect square, left over, x to the 50th, x left over, and the square root of x to the 50th is x to the 25th, rad x. Just take half of it. So L, M, and N is basically saying what happens when we add radicals. Well, the one thing you have to remember when you add radicals is that you have to make sure that just like with like terms, they have to be exactly the same. All right, so for example, with L, and I think I'm only going to do L. We can do M and N in class if you want to go back and take a look at them. So let's take a look at L, and we're going to take these separately. So in other words, I'm going to kind of forget about these for a second here, and I'm just going to look at that radical 18 x to the 3rd, y to the 4th. So we're going to pull out what's the perfect square and the what's left over. So I can take out a 9 times 2, an x squared with an x left over, and a y to the 4th with nothing left over. So this turns out to be 3xy squared rad 2x. Take a second, pause it, and really looking at these before you write them down is really what I suggest. So now we're going to forget about this one and look at this one over here. So we're adding these. Again, that's why I'm sorry, I'm going to go into M a little bit here. So 72 is going to be 36 times 2. If you're not sure what goes into it, divide it by 2, divide it by 3, things like that, and come up with a perfect square. X squared with an x left over, y to the 4th, with nothing left over. So you can see this comes out to be plus what? 6. Plus 6 xy squared rad 2x. So see how these are exactly the same? We have xy squared rad 2x, xy squared rad 2x. It's the only way that we can add these two together. So our final answer is 9xy squared rad 2x. So nothing changes behind the coefficients. We're just adding the coefficients because it's a plus sign. And as long as they're exactly the same, you can add them together. So if you want to try m and n on your own, basically you're going to be doing the same thing, and we can discuss them during class. So all of that we've looked at in exercise 1, we've really looked at before in algebra 1. I don't know how extensive your teacher took it, but you should come in with that skill of being able to break it down, or at least it should look familiar to you. But here in exercise 2, this is the new stuff. When we start taking our square roots and extending it to the third root, the fourth root, the fifth root, things like that, this is kind of new, but it follows the same exact format that we did with square roots. So when you start looking at numbers of cube roots, of fourth roots, of fifth roots, the first thing you really do have to do is take some time and just write them down. Because like you see, we have some numbers in here, and that gets a little bit confusing. So an A, B, and F, and E, we have cube roots. So let's take a look at what some of these cube roots are. So in other words, look at 2 cubed is 2 times 2 is 4 times 2 is 8. 3 cubed, 3 times 3 is 9 times 3 is 27. 4 cubed, 4 times 4 is 16, and 16 times 4 is 64. 5 cubed, 5 times 5 is 25, times 5 is 125. So you kind of get the gist here. So now what we're doing is we're just pulling out the cube root. So in other words, again, what we're looking for is what number times what number times what number is equal to 8. Has to be the same number. So in this case, the answer is 2, because 2 times 2 times 2 is 8. So the answer of the cube root of 8 is 2. Now we looked at obviously this one as well, because we just looked at this one being 5. We just looked at, okay, now the fourth root of something is 81. So you might want to spend some time looking at the fourth roots. All right, 2 to the fourth power is 16. 3 to the fourth power is 81. There you go. All right. So this one is going to be, the fourth root of 81 is going to be 3. Now, if you have numbers crazy like this, you can also use your calculator. So the fifth root of 7776. Now, if it's a perfect radical, now anytime you want to get your LOL button next to your 9, and right here, the fourth one in gives you different roots. So I can do the fifth root. Was it the fifth root? Now I forgot what it was. It was the fifth root. That's right. So the fifth root of 7776. If it's a perfect radical, it'll tell you that. So in this case, it's 6. So you can just put down 6. If it's not, at least it gives you an idea about what the number is. Let's go back here. So the answer to this one was 6. The third root of 16. Now I have my cube roots up here. So 16, obviously 16 falls in right between these two, and 8 is what's going to work. So cube roots, we're going to do the same thing that we did with the square roots. Perfect cube here, which is 8. What's ever left over is here. So remember, the leftover part stays, and the cube root of 8 is 2. So there's the answer simplified to E. So F is the cube root of 128. So what I just did in my calculator real fast is I took 128 and I divided it by 2 and I got 64. And I look up at the top and 64 is one of my cube roots. So it's 64 times 2. If that didn't work, I would have divided it by 4, because not 3, but I would have divided it by, I guess I could divide it by 3, by 4, by 5, anything that's not a perfect cube. All right, so 64 times 2. And now this time, this has to be divisible by 3. So I can take out x to the third, x to the sixth, commas here, x to the ninth, any multiple of 3 I can take out of here. So I'm going to take out x to the sixth, but in this case I have x to the second power left over. So this is going to be, now be careful when you do this part. It's very tricky because now your brain has to keep thinking about those cube roots. So my cube root of 64, I have that up here, is 4. 6 divided by 3 is 2. And then that cube root, now make sure you keep the 3 on the inside so it doesn't look like a power. 2x squared stays on the inside. Again, we don't touch this part. That's the part that we can't touch. It's not a perfect cube. All right, so just took a second and looked at 48. And when I looked at 48, we're doing the fourth root here. So I'm going to use those numbers up on the top right. And I just took 48 and I divided it by 2, and it turned out to be 24, which I didn't have to do that in my calculator. But 24 is not a perfect square, but when I divide it by 3, I get 16. So what that means is that 16 is a perfect fourth root, and then what's ever left over, which is the 3, goes over here. And this is the same pattern as before. I have 4 here, so here I can take out an x to the 4th, an x to the 8th, an x to the 12th, anything, any power of 4. So here I'm going to take out an x to the 8th, but then I have x squared left. I'm going to take out a y to the 4th, be careful with those 4's there, and I have a y left over. So this fourth root of 3x squared y can't touch it. It's not rational. But the other side is, and that's the reason we created this. So the fourth root of 16 is 2. Please be careful, because I can tell you that sometimes our brain crosses, the wires cross, and you say, oh, the square root of 16 is 4, because you're so used to working in those square roots. All right, so beware. Make sure you write your numbers down and kind of always glance at them. So the fourth root of 16 is 2. Then we take 8 divided by 4 is 2. 4 divided by 4 is 1. So I can either put the 1 in, you can leave the 1 out. It doesn't matter, but there's your answer. Nope, that's not your cue to leave. But now we're doing fifth roots. Ooh, this gets a little ugly. So the first thing we're going to do is take a look, and like I said, the first thing I always do is write down some of my fifth roots. Well, 2 to the fifth root is 32. 3 to the fifth root is 81. 3, let's see, 3 raised to the fifth power is, nope, 243. All right, so now when we do this, we take that fifth root and the fifth root, and we say 32 times 2. Remember, the fifth root of 32 is 2. X to the 10th, I have 2 left over. Y to the 15th with no y's left over. So I have 2 x to the second, y to the third, rad 2x squared. Okay, so I know this can be confusing, so if you need to pause, write things down, maybe re-watch things, maybe try some on your own and then watch the video again. Do what you need to do in order to really understand this concept. Because like I said, we're taking this from square roots to cube, fourth, and fifth roots very quickly. All right, so now what we're going to do is take a look at exercise 3 on the next page. And this is going to be solving rational roots, rational exponential equations. Sorry, can't talk. So here, what they do is they leave the exponents in rational form, which is fractional form, instead of giving you something that looks like this. So square root of x is equal to 7. Well, you know how to solve that. You would just square both sides. But the same thing is true when you have a rational exponent. Basically, what you're going to do is take your x to the 1/2, and you're going to raise it to the reciprocal, which is the 2 over 1. which is basically what you just did when you took the square root of it. So x equals 49. And we are looking for the positive because we're dealing with radicals here. We're only dealing with the positive root. So in this one, remember what this means. This means the cube root of x squared is equal to 64. So even if they had given it to you this way, the first thing we probably would have done is change it to a rational format, which is what they show you in B. So when you do this one, you're going to raise this to the 3 over 2. Have to raise this side to the 3 over 2. Remember, we're not multiplying it by 3 over 2. We are raising it to the 3 over 2. So these cancel to 1, and x is equal to, and this part you can put in your calculator, or you can translate this back and say this is the square root of 64 to the third power. The square root of 64 is 8, and 8 to the third power is something I don't know in my head. So 8 raised to the third power is 512. So x is equal to 512. And if you had just done 64 raised to the 3 halves, so if you had done 64 raised to the 3 divided by 2, you should still get the same number. So make sure you're paying attention to this one. This is raised to the negative 4 over 1 to the negative 4 over 1. So x is equal to 5 raised to the negative 4 is going to be a fraction, which is 1 over 625. Or you could represent it as a decimal, which is 0.0016. Either of these would be acceptable. D, we're going to raise this to negative 5 over 3, raise this to negative 5 over 3. And the reason we do that is because this will go to 1 then. So we have x is equal to, and then remember in our calculator, you make sure that you're using fractions, and I mean using parentheses. So it's going to be negative, I forgot what it was, negative 27 5 over 3. Negative 27 raised to the negative 5 over 3. 5 over 3. Let me just make sure that's right. To the negative 5 over 3, that is right. And enter, and you get negative 1 over 243. Negative 1 over 243. Now, just like solving equations, when we have E, make sure you are isolating your base. Your base in this case is your x. So just like before, algebra 1, add 31 to both sides. You get 1 over 5, x to the 3 over 4 is equal to 25. Now here, I can't do anything until I get rid of that 1/5. So let's multiply both sides by 5. So I get x to the 3 over 4 is equal to 25 times 5, which is 125. And if I'm going to do to the 4 over 3, to the 4 over 3, so 125 raised to the 4 over 3 is equal to 625. I'm going too fast. Make sure you pause. All right, so we're going to do the same thing on F. We're going to minus 5 from both sides. Remember, here's your road. Go back to what you know in Algebra 2, Algebra 1 if you have to. So minus 6x to the negative 3 over 2 is equal to negative 2058. Divide both sides by negative 6. So negative 2058 divided by 6, negative 6, is positive 343. So x to the negative 3 over 2. Remember, this is where colored pencils usually come into play. So negative 2 over 3 negative 2 over 3. So I'm going to take this and I'm going to raise it to the negative 2 over 3, and I get 1 over 49. Remember, that's what that negative tells you to do. It means drop it into the denominator. Okay, last two. Let's get these done. So in this case, here's the base. So we need to isolate that base. It's already isolated. So we're just going to take this whole term on the left-hand side and raise it to the 2/3. Raise this to the 2/3. So you're going to get x minus 3 is equal to, the cube root of 27 is 3, and 3 squared is 9. Easy enough there. Add 3 to both sides, and x is equal to 12. And here we're going to take the fourth root, so we're going to raise this to the 1/4 power. Raise this to the 1/4 power. Again, you can do that in your calculator, but the fourth root of 16 is 2. So you get x minus 7 is equal to 2. Add 7 to both sides, and x is equal to 9. So those last two were actually easier than the first three that we did. So remember, you should always be taking time at least looking at some of the independent practice so that when you come into class, you're ready to discuss this and you feel a little more confident about helping your group through these kind of problems. All right, so until next time, always make good choices and have a good one.